This video will go over lesson 21.1 special right triangles 45, 45, 90. So if you look at the first question, a square is given and the sides are given to be 1. And in a square, all the sides are going to be 1. Now to find the diagonal in this square, you look at the right triangle ABD. Since the leg is 1, and the legs are going to be equal to each other, so each leg is going to be 1, I can use Pythagorean theorem to help me find the diagonal, which is the hypotenuse. So the diagonal of the square is going to be the hypotenuse of the right triangle ABD. So I can use Pythagorean theorem and label the legs to be A and B and the hypotenuse to be C. So A squared plus B squared is equal to C squared. Now, A squared is 1 squared plus 1 squared, which is 2, is equal to C squared. Then to solve for C, I square root both sides, and I can get that C is equal to the square root of 2. So in this case, I found the sides to be 1, and then the diagonal to be root 2. Now, if I want to think about the square itself and the angles, if this is 90 and the legs are equal, because all sides in a square are equal, then this is a right isosceles triangle. It's a right isosceles triangle because it is right, because of the right angle, and because the two legs are congruent, so this is an isosceles triangle. So if this is 90, you can do 180 minus 90 is 90. And since the sides are equal, the angles are going to be equal as well. So this is going to be 45 degrees, and this is going to be 45 degrees. So this is a right isosceles triangle, and this will also be a right isosceles triangle. So a square is always made up of two right isosceles triangles. And another name for the right isosceles triangle is the 45, 45, 90 degree triangle, because the angles are going to be 45 and this angle is going to be 90. So this is one of the special right triangles we're going to be talking about, the 45, 45, 90, or in other words, the right isosceles triangle. So now what we're going to do is try to use Pythagorean theorem to help me find the hypotenuse. And once I do that, I will come up with a pattern that I can always use to find missing sides in 45, 45, 90 degree triangles. So if I look at the first triangle, if the legs are 1, then the hypotenuse is square root of 2. So then I know that this hypotenuse is going to be square root of 2. What about this triangle? I know that the legs are 2 and 2, so A squared plus B squared is equal to C squared. So these are the legs, and this is the hypotenuse. So 2 squared plus 2 squared is equal to C squared. So 4 plus 4 is equal to C squared. 4 plus 4 is 8. So if I want to solve for C, I square root both sides. Now to be able to square root 8, I have to think of two numbers that multiply to give you 8, which are 4 and 2. So the square root of 4 is 2. I cannot square root 2, so that remains inside the radical. So the hypotenuse is going to be 2 root 2. So let's look at the pattern. If the leg is 1, the hypotenuse is 1 root 2, which is just root 2. If the leg is 2, then the hypotenuse is 2 root 2. So it seems that I'm always multiplying the leg by square root of 2 to get the hypotenuse. So if the leg is x, that means that the hypotenuse is going to be x root 2. So when I say 45, 45, 90, the 45 represent the leg is the side in front of the 45. The leg is in front of the 45 degrees, and the hypotenuse is opposite of the 90 degree angle. So then if the leg is x, the hypotenuse is x root 2. So from now on, to be able to solve the problems 1 through 8, You don't have to use Pythagorean theorem anymore. You can use the pattern to help you find the missing sides. So let's start on number 1. Always highlight the hypotenuse, which is the side opposite of the right angle. You can notice that this is the 45, 45, 90 degree triangle, so you can use the pattern that we just talked about, which is x, x, x root 2. In this case, I know that the leg is 5. So then all of the legs are going to be 5. The 2 legs are going to be 5. And then the hypotenuse will be x root 2, which is 5 root 2. So then the leg is 5, and the hypotenuse is going to be 5 root 2. Now let's move on to number 2. Highlight the hypotenuse. So the hypotenuse is 6 root 2. So if this is x root 2, that means x is going to be 6. So then the legs are going to be 6. Let's move on to number 3. This one is a little bit different. So in this case, the hypotenuse is needed, and the one of the legs is given to be 4 root 2. Again, this is a special right triangle, so the legs are going to be equal to each other. So then a is going to be 4 square root of 2. Now to find the hypotenuse, I need to remember that the hypotenuse is x root 2, which means it's going to be the leg times root 2. In this case, it's not as easy to use the pattern. That's why it's better to think about it as leg times root 2. The leg in this case is going to be 4 square root of 2. If you multiply that by root 2, remember when you multiply a radical by itself, the radical goes away, so that's going to be 2. And you're multiplying that by 4, so 4 times 2 is 8. So remember, the leg itself is 4 root 2. So you need to multiply the leg by root 2, and you were able to find that the hypotenuse is 8. Now let's move on to number 4. If the hypotenuse is equal to leg times root 2, then the leg is equal to hypotenuse divided by root 2. So that's the opposite operation. In this case, the hypotenuse are given to be 10. So again, it's not as easy to find to use the pattern, so it's better to think about the equation. So the leg is equal to the hypotenuse divided by root 2. The hypotenuse in this case is 10. 10 divided by root 2 is going to be the answer. But you cannot have a radical on the bottom of the fraction, so you rationalize by multiplying the top and the bottom by root 2. So 10 times root 2 is going to be 10 root 2. And root 2 times root 2 is 2. 10 and 2 simplify to give you 5. So then the final answer is going to be 5 root 2. So before we continue, I would like to summarize what we just said in a sketch to help you remember the rules. So remember, one of the special right triangles that we talked about today is the 45, 45, 90 degree triangle. And another name for it is the right isosceles triangle. The pattern is x, x, x root 2. Sometimes it's easy to use the pattern, sometimes it's not. So let's sketch a right isosceles triangle, which means that the legs are going to be equal to each other, and the angles are going to be 45 each. So if the leg is given, remember you can multiply the leg by root 2 to get to the hypotenuse. So leg times root 2 will give you the hypotenuse. And if you have the hypotenuse, you can remember that you need to divide by root 2 to get to the leg. So I hope this helps you remember the rules. So remember, the leg is equal to hypotenuse divided by root 2. And the hypotenuse is equal to leg times root 2. So that's the summary. Now let's move on to number 5. The leg is given to be 15. So this is a right isosceles triangle, so the other leg will be 15, and the hypotenuse would be 15 root 2. So again, this was a direct application of the pattern. So x, x, x root 2. So the leg was 15, and the hypotenuse is 15 root 2. Now if I move on to number 6, the hypotenuse is given to be 14, so this one needs a little bit of work. So remember, if you want to find the leg, you need to divide the hypotenuse by root 2. The hypotenuse in this case is 14, so 14 divided by root 2. You need to rationalize. You cannot have the radical on the bottom, so you multiply the top by root 2 and the bottom by root 2. 14 times root 2 is 14 root 2. Root 2 times root 2 is 2. When you multiply a radical by itself, the radical goes away. 14 divided by 2 is 7. So the answer is going to be 7 root 2. So in this case, both legs are going to be equal to 7 root 2. Now let's move on to number 7. The length of each leg of a 45, 45, 90 triangle is 9. So I'm going to sketch this triangle they're talking about. So it's a right isosceles triangle where the legs are going to be equal to each other. And they said, so the legs are equal, so then the angles are going to be 45, 45, and 90. The leg is 9, so this is a direct application of the pattern. If the leg is 9, then the hypotenuse is going to be 9 root 2. Now, they're asking for the perimeter and the area of the triangle. Now, remember, if you want to find the perimeter of a triangle, you have to add all of the sides. So 9 plus 9 plus 9 root 2. Now combined like terms, these two are whole numbers, so I can add them. 9 plus 9 is 18. 9 root 2 is not a whole number. It has a radical with it, so I cannot combine it with the 18. So the perimeter is going to be 18 plus 9 root 2 units. Now to find the area of this triangle, you need to remember that the area of a triangle is base times height divided by 2. So the base and the height are the ones who are perpendicular to each other. They are the ones forming a 90-degree angle. So in this case, the two bases, the base and the height, are the two legs. So then 9 times 9 divided by 2. So that's 81 divided by 2, which is 40.5. And because it is area, it is going to be units squared. Now let's move on to number 8. The diagonal of a square. So we have a square, so let's sketch a square. And the diagonal of this square is going to be 20 root 2. So remember what we said earlier in the notes, that a square is made up of two right isosceles triangles, which is two 45, 45, 90-degree triangle. So I know that this square is going to be a right isosceles triangle. So this is going to be 90. The legs are going to be equal to each other. So I can use the pattern x, x, x root 2. So if the hypotenuse of this right triangle is 20 root 2, then the legs are going to be 20 each. And because this is a square, then all the sides are going to be congruent, all four sides. So if I want to find the perimeter of the square, that's going to be 20 plus 20 plus 20 plus 20, or 20 times 4, which is 80 units. So that's how you solve problems with the special right triangle 45, 45, 90-degree triangle.